Hey guys, so for our second class this week, we're going to learn a different integration technique. Basically, when all else fails, what else could we possibly do? So it kind of goes along in the section of like, all right, do we use long division? Do we rewrite as the sum of two quotients? Do we complete the square? All right, does regular u and du not work? What do we try next? So there's something called change of variables in section 4.5 when we first learned integration by substitution. So example 1, if I gave you this problem back in chapter 4, you'd be able to do it. All right, what would you make u? You would make u the inside. Your du would be 3 dx. So you actually have to put a 3 in, multiply by 1/3 on the outside. And here you're integrating this square root of u du. So you would rewrite that as 1/3 the integral of u to the 1/2. And when you integrate that, you add 1 to the power. So it would be u to the 3/2, right? When you add 1 and divide by 3/2, it's the same thing as multiplying by 2/3. So you end up getting 2/9 u, which is 3x plus 1 to the 3/2 plus c. Okay, so that's nothing different than we've learned before. What's different is number 2. So when you go ahead and you try to make u the inside here, 3x plus 1, your derivative, right, is 3 dx. And you're saying to yourself, well, wait a second. I got this extra x left over. What am I going to do with that? It doesn't mean that you did anything wrong. There's literally no other integration technique that we can use. So you can do something called change of variables. And, we know what u is going to stand for. We know what du is going to be. But we have this extra x. So what if we took this equation here and we solved for x? So that means I subtract 1 to u, right? And then I divide by 3. That's what x equals. Okay, and then our dx, right, a derivative of x would actually be 1/3 times du. So let's actually look at this differently. So what we're going to do is we're going to replace everything in here. X is this right here. So x is 1/3 u minus 1. I just wrote it differently. It's the same thing as saying u minus 1 over 3. This right here is going to be the square root of u. And the dx, right, the dx is this right here, is the 1/3 du. All right, everything's in terms of u now. You don't want to have u's and x's together. So what you're going to do is you're going to clean this up. You're going to bring the 1/3 times 1/3 out. What you're going to have is u minus 1 times u to the 1/2 times du. You still can't integrate it like this. What you want to do is distribute this u to the 1/2 to both terms. So it would be u to the 3/2 minus u to the 1/2 du. And now we're going to integrate it separately. So it'd be 1/9 u to the 5/2 divided by 5/2 is the same thing as multiplying by 2 over 5. Minus the 1/9 also goes to the second part here. U to the 3/2 and divided by 3/2 is the same thing as multiplying by 2/3 plus c. And now we're just going to clean it up and plug our u back in. So this ends up being 2 over 45 u, which is 3x plus 1 to the 5/2, minus, this becomes 2/27. Plug your u back in, 3x plus 1 to the 3/2 plus c. And there you go. So a little different. So basically, if you see a square root or a parenthesis, you try to make u the inside. But if you have stuff left over, like an extra x left over, you can think of it differently and say, all right, well, let me solve for x now in terms of u. Then find my dx or my derivative of x from there, and let's now substitute everything in, and does that put it all completely in terms of u? And if it does, then you integrate from there. All right, so let's look at example 5 here. Okay, same thing. Your gut reaction would be make u the inside of the square root, or if you had a parenthesis, the inside of that. My du would be 2 dx. Now you say to yourself, I got this extra x left over. So what you're going to do is, from the u, you're going to solve for x, and that would give you u plus 1 divided by 2 when I solve for x here. And my dx would be 1/2 times du. So now we're going to replace everything. Don't worry about the bounds right now. We'll talk about that in a second. These bounds are in terms of x, remember, okay? So what we're going to do, okay, I'm going to replace, or x, I'm sorry. I'm going to replace it with this right here. So 1/2 u plus 1. All right, my dx, I'm going to replace it with this right here, is 1/2 du. And on the bottom is going to be the square root of u. All right, so we got to clean this up. So I'm going to bring both halves out. That makes it 1/4. The integral of u plus 1 divided by root u times du. All right, we still don't like this form. We don't want to integrate the way it is right now. So this is u to the first. So u to the first divided by u to the 1/2 is u to the 1/2 when you simplify. Plus 1 over root u becomes u to the negative times du. And now we're going to integrate from here. So you get 1/4 u to the 3/2, and divided by 3/2 is the same thing as multiplying by 2/3. And then plus 1/4 again, because this 1/4 is technically distributed to both parts. U to the positive 1/2 and divided by 1/2 is the same thing as multiplying by 2. All right. Now, before I put plus c, I'm not going to put plus c because I have these bounds that I'm going to put in, and I don't want to put the bracket yet because I want to talk about something. So I want to simplify in here first. So this is going to be 1/6 when you reduce this 2 and that 4, u to the 3/2 plus, and then this 2 and that 4 reduced to 1/2, u to the 1/2. Now, you have two options here. Don't put 1 and 5 here because 1 and 5 are in terms of x. Here's what you could do. You could solve for what u is by plugging this x, and let me use a different color. I'm taking this x and plugging in here. So that bottom bound, if I want it in terms of u, if I keep this in terms of u, I need these bounds to be in terms of u. So if I plug 1 in here, I get 1. If I plug 5 in here, I get 9. So now I literally could just plug those numbers in. I don't have to write it back in terms of x because I changed the bounds to be in terms of u. This is something a little bit different. So I'm plugging in 9 to both parts first. And then subtracting, take 1 and plug it in. So 1 to any power is just going to be 1. So that's easy, plugging in 1 for these u's. And now we simplify this. So we get, what is this? This is the square root of 9, which is 3. And then 3 cubed is 27. So this is 27/6 plus, and then the square root of 9 is 3. So plus 3/2. And then minus 1/6 minus 1/2. So you end up getting 27/6 plus 9/6, right? 3 minus 1/6 minus 3/6. So your final answer, you end up getting, let's see, 36 minus 1 is 35. Minus 3 is 32/6, which reduces to 16/3. Okay. Now, you could have also done this. And I want to show you both ways, because in college, you never know what your professor is going to teach you, and I don't want you to be like, what? I've never seen that before. You could do what we used to do, which is take your u and plug it back in. So I'm going to make it back in terms of x. It's 2x minus 1 to the 3 halves plus 1 half times 2x minus 1 to the 1 half. And make your bracket to show you're still plugging in these x bounds. Now I'll use 1 and 5 because now it's in terms of x. So you should get the same answer. If I plug this in, I get 1/6 times 9 to the 3 halves plus 1/5, or sorry, 1 half, 9 to the 1 half, then minus, now take 1 and plug it in. That's going to give me 1/6, right? This becomes 1 on the inside. This becomes 1 on the inside. And you're right back to this step right here. So you should get the same answer. You have a choice. I don't care which way you do it. Choose whatever's easier for you. All right, but I wanted you to be able to see that. Okay, this next one here, let's see. What color do I want to use? All right, what would you make u? Right, the inside. So my du would be 4x cubed dx. All right, there's nothing crazy that we have to do here. You have an x cubed dx in there. All you need to do is put in a 4 and a 1/4 on the outside, and to the negative 1 half du. Okay, this is du over u to the 1 half, and you bring that up, and you use your normal power rule. So it'd be u to the 1 half, and divided by a half is the same thing as multiplying by 2 plus c. So it ends up being 1 half my u, which is 1 plus x to the 4th, to the 1 half. I like writing it as a square root better, but I don't care if you write it to the 1 half plus c. All right. And last, let me move a couple. Actually, you know what I'm going to do? You guys are going to do 5, 6, and 7 as your homework. And that's it. Okay? All right. I will talk to you guys later.